Welcome back to the Elemental series of instructional videos. In this particular video we're going to look at, some of the inherent structure types that emerge from the use of brick as a material. Now, intrinsically, brick is a compression or a mass construction type of material. A very, popular or famous conversation Louis Kahn had with his students discusses the sort of brick as and tries to distill its inherent characteristics. And this rather sort of strange conversation where the brick and a sort of a window opening have this interplay, and when you ask, of the brick, what do you want of the brick, as Louis Kahn says, the brick intrinsically wants to be a compression structure, in this case an arch. I like an arch, says the brick. And the bricks, you come back to the brick and say, well, look, arches are expensive, but I can use a concrete lintel. And yes, it does actually address the technical issue of working with a compression structure like a brick, but it's not the intrinsic character of it. And so the brick comes back and says, I like an arch. So it is, the character of the brick, and a lot of the sort of structure types that come out of it are based in that sort of transfer of load in the most efficient way, avoiding as much tension as possible. So from traditional, Roman pointed, and as we discussed in an earlier workshop, catenary arches, and even sort of more contemporary expressions of the arch as a jack arch, which is using sort of friction and the shape of the bricks to make an arch-like structure, although it is flat. But again, these require the skill of a master craftsperson, which is why that we end up actually looking at lintels, both precast concrete and steel lintels over openings. But although we can do it, it's not the intrinsic nature of the material. Extending this on to, the sort of structure types, if we look at the sort of natural evolution, then we start with the arch, and as a sort of a two-dimensional expression. Extended out, it becomes the vault. And the interesting thing with a lot of refined, more traditional architecture using compression or brick types of structures is when you start to use some of these compression structures in combination. So you intersect two vaults together, you get a groin vault, which is the basis of a lot of quite impressive stone and masonry Gothic buildings and buildings through the century. Very beautiful, very simple, but very direct expression of the material. And combining these, like a dome is a half an arch that's rotated, and then combining these again, it just through the dome and the groin vault get very complex structures and sense of space. But again, very sort of direct compression load path. It's more traditional, easier structure, not necessarily easier to make, but again it's intrinsic to the type of material. Not so much again done in contemporary construction, where we're using more hybrid structures and composites and so on, but it is the sort of genesis of the brick. Now, part of the issue with brick walls is that the impression is that they're very strong. Well, they are, but in themselves a single thickness of brick wall at a certain height actually becomes quite weak, and it is possible to almost push it over just with a bit of force from people pushing against it. And there's a point where the slenderness or thinness of the wall starts to become a problem for its sort of structural integrity. So it's not possible to express that thinness of the brick, and it's where the sort of massness of the brick comes on board, because it's intrinsic to its structural capacity and the structure systems that are associated with it. Now, basically what you want to do is find a way of shortening the lengths between I guess joins, and also to sort of give a bit of stiffness to reduce that problem of slenderness. The traditional way is to introduce a series of engaged piers that gives a more stiff wall, or even just relying on the internal partitions which are tied into the exterior wall to give that external wall stiffness. And even in some contemporary situations, introducing a curved geometry or bending the wall in some way also helps to give the wall extra structural stability. And again, just adding an extra leaf and interleaving the two walls together, the thickness and the fact that they're joined again gives a much more inherently strong proposition. And in the traditional sense, the brick walls would often, the thickness would get sort of wider and thicker down the bottom as a direct, I guess, expression of the load paths coming from the building, which are lighter at the top, and as the accumulation of load goes down through the building, the walls get thicker in response to picking up those loads. Now, when we start to talk about double leaves and solid masonry walls, they do need to be tied together in some way. Now, in contemporary situations, we do have metal ties, but in traditional and even in some landscape walls and so on, we do use what's called header courses to, I guess, tie the two leaves together. So here we can see two very straightforward stretcher bond walls, and we've put a header course to tie the two together. And in the top one, the header course is a flat brick going through, so again you can keep a consistent coursing height, or a different one which is called a row lock, which is tipping the brick on the side and introducing it sort of that way. It's often used as a sort of a capping type of material, because what it does, particularly with because most bricks will either have an extrusion or a what they call a frog in the brick itself, the header course will mean that not a fair face or a finished face would be exposed unless it was a special brick. Using a row lock, tipping it on its side, you actually get the finished face facing upwards to do all of the weathering. Now, traditionally, there has always been a series of techniques of how to lay bricks, and this is partly in terms of, I guess, a brick tradition in countries where brickwork is intrinsic to the craft of building. But we always also need to look at the sort of technical capacity of different ways of combining bricks to give it more or less strength. Now, most buildings using sort of contemporary brickwork, single skin or double skin brickwork, use what's called a stretcher bond. It's a very simple offset, very repetitive pattern. There's not a lot of I guess subtle articulation in it. It's a simple bond. It's probably not the strongest bond, but it does have minimal waste, and it is very fast to construct. Now, other countries with a strong brick tradition will have variations of this as well. So what they call an American bond is like a stretcher bond, but with a header course every sort of 5 to 7 courses or rows. You can see there's a little bit of complexity in here, but again, very little waste. So in order to get the header course to work with the unit of the brick at the corner, which is where most of the trickiness of these coursing and bonds is executed, you can see a brick is cut with a quarter of it sliced off, and a 3/4 brick used at the corner. The quarter fills the void on the inside of the brick, and it means that you can then introduce a header core so that the header coincides with the perp ends of the brickwork below. An English bond is quite different. It is perhaps just as efficient, but it's not a very commonly used brick bond in our country, at least now. But you will find some older buildings, some older mass brick buildings that use an English bond. Now, the English bond is quite unusual in a way. It's a very subtle, I guess, variation in pattern, because if we look at the example we see on the screen now, the bonds on the left are sort of almost offset by one course on to those on the right. So the patterning is sort of offset, and there's a sort of a subtle jarring in that when you look at them on three-quarter view at the corner. With sort of dark coloured bricks and reds and so on, you don't really notice it, but you have to do a double take to actually pick that up when you're just looking at it for the first time. Now it relies on what's called a queen closer. You can see that's the special brick which is coloured. Now what that is a brick that's cut down the length. So it's cut in the middle, but not in the middle ways, but in the long sort of section. Now that's a very difficult cut to do well, and so again it's something that someone with a bit of skill has to execute. Now probably my favourite is the Flemish bond. It is complex, and you need to sort of concentrate always how it goes together. But again, it's and there is a little bit of waste, because it uses a three-quarter brick at the corner to make it work, and it doesn't recover that quarter anywhere else. But it's the Flemish bond is very strong. It's reasonable in terms of the way it uses material, but it gives a sort of a varied patterning, but a consistent patterning as well. It's almost like a basket weave. It's using contemporary bricks, I guess, which are very uniform. It does help to sort of break down that sort of monotony that you see with stretcher bond bricks, and it does respond very well to sort of polychromatic patterning and so on. Again, it's something that perhaps a lot of bricklayers here would be unfamiliar with, and it would slow them down. A lot of them would find it very troublesome, but it is a very elegant and beautiful to look at sort of brick wall. So that's finalises that next section where we covered, I guess, the structure types, and I guess the sort of technical aspect of the bond patterning and the aesthetic capacity. Thanks again for listening, and hope that you catch the next videos in the series.